Right now, at the exact center of our galaxy, something enormous is lying completely still. It has been quiet for longer than modern humans have existed, but quiet is not the same as harmless, and scientists have started asking a question that sounds like science fiction but isn't. What happens the moment it stops being quiet? 26,000 light years from where you're sitting right now, there is an object 4 million times heavier than our sun, and it is doing nothing. No flashing lights, no warning signs, just silence. But every galaxy we've ever pointed a telescope at that isn't silent looks like a war zone. Beams of radiation blasting out for thousands of light years, gas heated to temperatures that shouldn't exist, entire star systems torn apart in an instant. And the only difference between those galaxies and ours is one thing: whether the giant at the center is asleep or awake. Ours has been asleep for a long time, so what actually wakes something like this up? And if it happened, not in theory, not in a million years, but starting tomorrow, how long would we actually have before it mattered? The answer is stranger, and in some ways more unsettling than you'd expect. Because the scariest part isn't the destruction, it's how long we'd have absolutely no idea it was happening. Every large galaxy we've observed appears to have one of these hiding at its core, an object so dense that not even light can escape it once it crosses a certain boundary. Ours is called Sagittarius A star, sitting almost exactly at the midpoint of the Milky Way, roughly 26,000 light-years from Earth, with a mass equivalent to about 4 million suns compressed into a region smaller than our solar system. We only got direct visual proof of it recently. In 2022, the Event Horizon Telescope collaboration released the first actual image of it, a blurry orange ring of superheated gas wrapped around a black core, the shadow of the black hole itself. It confirmed decades of indirect evidence. Stars near the galactic center have been observed whipping around an invisible point at incredible speeds, some completing full orbits in less than 20 years, which for an orbit on a galactic scale is almost impossibly fast. That speed only makes sense if something with an enormous, concentrated mass is anchoring them. Here's the part that matters for this video, though. Compared to black holes at the centers of other galaxies, Sagittarius A star is remarkably calm. Some galactic centers glow so brightly with radiation that they outshine every star in their galaxy combined. These are called active galactic nuclei, and the brightest versions are called quasars. Sagittarius A star produces none of that. It sips gas occasionally, flickers faintly in X-rays, and otherwise just sits there. Astronomers describe it as dormant, which raises an obvious question. Dormant things can wake up. So what would actually flip the switch? It's not random. Black holes don't activate on their own. They respond to what falls into them. And the amount of light and radiation a black hole produces is almost entirely a function of how much material is spiraling into it at any given moment. Right now, the gas and dust drifting near Sagittarius A star is thin, and it's falling in slowly and quietly. That's the entire reason our galactic center looks calm, but we already have proof this can change fast. In 2014, astronomers watched a gas cloud roughly 3 times the mass of Earth, nicknamed G2, swing dangerously close to Sagittarius A star. For months, everyone expected fireworks, a burst of radiation as material got shredded and consumed. It turned out to be a near miss. G2 survived largely intact, and the black hole barely reacted. But it revealed exactly the kind of event that could trigger a real awakening, something wandering too close, getting caught, and beginning to spiral in. Now scale that up. Instead of a loose gas cloud, imagine a full star drifting into the wrong orbit. We've actually observed this exact scenario happen in other galaxies. Astronomers call it a tidal disruption event, where a black hole's gravity stretches a star until it's torn apart into a stream of superheated debris, and that debris lights up as it falls in. When it happens elsewhere in the universe, it can outshine the entire galaxy around it for weeks. If that happened here, at home, the quiet giant at our galaxy's center would stop being quiet almost immediately. And here's where it gets strange, because even if that happened starting tomorrow, what you'd actually experience here on Earth is not what you're picturing. Let's say it happens. A star strays too close, gets caught, and starts spiraling into Sagittarius A star tomorrow. Here's the sequence based on what we've observed happening around other galaxies' black holes. First, the star gets stretched, a process astronomers grimly call spaghettification, where the side of the star closer to the black hole is pulled so much harder than the far side that the entire star elongates into a thin stream of gas. That stream doesn't fall in cleanly. It whips around the black hole and forms a swirling disk of debris, and as that debris rubs against itself at close to the speed of light, it heats up to millions of degrees. That's when the light show starts. The disk begins glowing first in X-rays, then across the spectrum as more and more material funnels inward. In observed tidal disruption events in other galaxies, this brightening can happen over just days to weeks, not centuries, not millennia. Some jets of particles get blasted outward from the black hole's poles at close to light speed, a phenomenon we've directly observed in other awakened galactic centers. If this happened at Sagittarius A star, the region at the center of our galaxy would begin outputting radiation on a scale it hasn't produced in possibly millions of years. Not enough to destroy the galaxy, the mass involved is still tiny compared to the black hole itself, but enough that if we had instruments trained on the galactic center, we would see an unmistakable dramatic brightening unlike anything currently on record. But here's the twist nobody expects when they first hear this scenario: that dramatic brightening wouldn't reach us tomorrow, or next year, or possibly for a very, very long time. This is the detail that changes everything about how you should feel about this scenario. Sagittarius A star is roughly 26,000 light-years away. That means the light and radiation from an awakening event wouldn't arrive at Earth until 26,000 years after it happened. If it woke up tomorrow, we on Earth would keep observing the same calm, dormant black hole we've always seen for over 26 millennia, before any sign of change ever reached our telescopes. So the immediate aftermath isn't really about Earth at all. It's about what's happening in that 26,000-year gap, unseen, unfolding in real time somewhere we can't yet perceive. Around the black hole itself, the picture would be violent. The destroyed star's material would keep raining in for months or years, the accretion disk would stay bright, and any stars or gas clouds unlucky enough to be nearby could get caught in the same disruption, potentially triggering a cascade of smaller events. Meanwhile, closer to home, absolutely nothing would visibly change, no warning, no red sky. Earth's night sky tomorrow would look exactly like it does tonight. That gap between something enormous happening and us having any way to know it happened is arguably the most unsettling part of this entire scenario. It means an awakening could, in principle, already be underway right now, and we would have no way of knowing for thousands of years. So assume the light finally arrives, 26,000 years from now. What actually changes for a civilization on Earth at that point? Realistically, less than you'd think. Even a fully awake Sagittarius A star, actively feeding and blasting out radiation, would be roughly 26,000 light-years away, far enough that the radiation reaching Earth would be a faint glow in specialized instruments, not something visible to the naked eye or dangerous to life here. Active galactic nuclei in other galaxies don't sterilize their entire galaxy. Their most intense effects are typically concentrated within a much smaller radius near the core itself. Earth sits far out in one of the Milky Way's spiral arms, comfortably outside that danger zone. The bigger long-term implication isn't about physical danger to Earth. It's about what an awakening would teach us. Every active galactic nucleus we've studied has been in a distant galaxy, observed as it already was, with no way to watch the before state. An awakening at our own galactic center would be the first time in human history we could observe this transformation from calm to active in real time in our own cosmic backyard, using instruments we built ourselves. It would rewrite our understanding of how supermassive black holes evolve, how often these events happen, and what triggers them. questions we currently can only answer by studying other galaxies from unimaginable distances. In a strange way, the danger story flips into a front row seat story. The giant at the center of our galaxy is capable of this. The only real question is timing, and given how vast cosmic timescales are, asleep for millions of years, and could wake up literally any day, aren't actually a contradiction. So Sagittarius A star has been quiet for a very long time, but quiet was never a promise. Somewhere out there, other galactic centers made the opposite choice, and the results are some of the most violent, most misunderstood objects in the entire universe. There's one in particular that doesn't just wake up occasionally, it never really sleeps at all, and what it's capable of makes everything we just talked about look small. If you want to see what a black hole looks like when it truly loses control, that's the video to watch next. What do you think? If Sagittarius A star really did wake up tomorrow, would you want to know? Drop your answer below.